Single replacement reactions are another common chemical reaction type. Single replacement reactions are a type of oxidation-reduction reaction. An oxidation-reduction reaction is also called an electron transfer reaction. Here are a few examples of oxidation-reduction reactions. In an earlier video, we saw how acid-base reactions involve give and take. The same is true with oxidation-reduction reactions. The difference is in what's given and taken. Stop the video, review these definitions, and then answer these two questions. And the answers are... Here is a very common oxidation-reduction reaction. Stop the video and see if you can answer these questions. And the answers are... Iron reacts with oxygen to form rust. Remember, elements have the same number of protons and neutrons so the charge equals 0. But an element in the compound does have a charge. A compound is a neutral substance, so the sum of those charges should equal 0. Iron is oxidized and is the reducing agent. Oxygen is reduced and is the oxidizing agent. In an earlier video, we classified elements as either metals or nonmetals. Stop the video and fill in those two blanks. And the answers are... Metals lose electrons to form cations. A cation has a plus charge. Nonmetals gain electrons to form anions. An anion has a minus charge. Stop the video, find a periodic table, apply these rules so you can fill in these blanks. And the answers are, based on the charge of oxygen and the chemical formula of rust, we can determine the charge on iron. Rust costs a lot of money, so it's important you try to protect substances from rusting. Here are 5 ways to protect a substance from corrosion. We'll try these in lab. Method 3 is to apply a protective coating. Note that a lot more money is spent on decorative coatings than protective coatings. Here's how self-healing paints work. This is the galvanizing process. Stop the video and identify the purpose of each step. And the answers are... Galvanized steel is designed to be maintenance-free for decades, so there's a lot of science involved in galvanized steel. So let's review. Stop the video and answer these questions. And the answers are... In an earlier video, we looked at how acids can be strong or weak. Same is true with oxidizing agents and reducing agents, so stop the video and answer these questions. And the answers are... We all use batteries. A battery uses an oxidation-reduction reaction to convert chemical energy to electrical energy. We know that metals lose electrons. Different metals have a different ability to lose electrons. In other words, different metals have a different activity. In a battery, 2 different metals are connected together. Electrons flow from the more active metal to the less active metal. You'll learn more about batteries in Chem 1B. An active metal easily gives up electrons. An inactive metal does not easily give up electrons. This table shows that lithium is the most active metal. Gold is the least active. Metals are also reducing agents, so lithium is the strongest reducing agent. Gold is the weakest. Stop the video and read the meaning and how we can use the activity series. Here's an example. Iron reacts with any ion below it on the table, but it will not react with zinc ion or lithium ion. Here's how we can predict the products. If iron reacts with copper 2 plus ion, the products will be copper and iron 2 plus ion. Here's an application of the activity series. A few years ago in Flint, Michigan, high lead levels were found in drinking water. That is very bad news. Here's where the activity series comes in. If the new copper pipes come in contact with the old lead pipes, electrons will flow from the lead to the copper because lead is more active than copper. This causes the lead to oxidize to lead 2 plus ion, and that gets released into the water. Earlier in this course, we looked at double replacement reactions. Now we'll look at single replacement reactions. In a single replacement reaction, an element reacts with a compound to form a new element and a new compound. Stop the video, review the example, and then determine what's being oxidized and reduced. And the answer is, according to the activity series, copper is more active than silver. So copper reacts with silver ion to produce silver and copper 2 plus ion. Let's do another example. Stop the video, determine the products of this reaction, and answer these questions. And the answers are, and for our ionic equation, remember, the element is not the same as the ion. Finally, lithium is more active than zinc according to the activity series, so this reaction will occur. The activity series can be used to determine whether you can plate one metal onto another. So place silver metal into a solution of copper 2 plus ion. Will the silver get plated or covered with copper? Stop the video for a minute and think about it. And the answer is no. Silver is less active than copper, so this reaction will not occur. What happens when you place copper metal into a solution of silver plus ion? Stop the video and see if this reaction occurs. And the answer is yes. Copper is more active than silver, so this reaction should occur. For our net ionic equation, and the activity series can be used to predict the net ionic equation. When you do this experiment, you'll actually see the copper metal turn a silver color. Let's say you want to protect an iron part from rusting. Stop the video and figure out what metal could you use to plate onto iron. See the activity series for the answer. A metal reacts with any metal ion below it on the table. For the metals given in this table, you could plate iron with copper, silver, or gold. In part 2 of this video, we'll look at some other applications of single replacement reactions and the activity series.